Good morning and welcome to today's webinar. Today's topic will be on ramp terminal details or Gore areas. This is a topic that came up in a few support calls here in the office, and I wanted to just go ahead and get a recording out there that would sort of detail out the steps, the workflow process, and give you all some ideas as to how to model these things. This is just another one of the basic detailing of your corridor design. You can see I've highlighted in green there that this is the ramp terminal detail areas or the Gore areas. There's a little definition down there as far as what the term Gore stands for. It's basically when two roads either merge or diverge, and there's a transitioning area happening between there, of course. The one thing that you'll see that I normally do is to basically plan ahead, try to decide where I'm going to use the templates and where to use the detail modeling. And in this case, I've also got, and actually that isn't a 2D or 3D yet, but it may be in the future. It's actually 2D civil cells. I'm going to show you some work that we've started here as far as laying out the 2D planimetrics and building some civil cells that will help automate that process that you're currently doing, just laying out with either microstation or civil geometry or both. Basically the steps, and I'm just putting these together roughly right now, but at least you'll have something to refer to. The general workflow steps are that you're going to lay out your baselines, obviously, for your center line, your main road, and then your ramp baselines. From there, you're going to build, obviously, the planimetrics that go with those. For example, the edge of pavements, the shoulders, and then the Gore areas. And this second step says use ramp terminal civil cell. I'm going to demonstrate that this morning. After you've got them laid out, the 2D wise, then you'll go in and determine where to drop in templates. Now there's a few different ways of doing this, but I've come up with a recommended approach, and that is that you would essentially have 4 template drops through your Gore area. The main goes right up to where the ramp starts to veer or diverge off of the main edge of pavement. And then between there and the end of the physical pavement of the Gore area, you would have a second template stage. And I'm going to show you all this in a corridor. And then the third stage is really the same as the main, except for you have the extended, it's really the taper of the pavement back into the main line after the physical Gore. And then you'd have the ramp as its own template drop through its own corridor. Once you have all those templates laid out, you can define your corridors and basically build them and use a template drop interval of 10, or in this case I use 2 feet just to make it a little more detailed. And then you can go ahead and get into the superelevation model for your ramp and actually calculate it based on the rural tables or the ramp tables for the maximum super based on the curvature of your ramp. You don't have to associate it to the ramp yet, but you can at least define it out there. And then the key really topic for detailing Gore areas, as most of you know, is trying to establish the profile, the beginning profile on the ramp, so that it will basically be a consistent slope off of your edge of pavement, or like a 3% slope, to where it becomes independent, and then having the Gore area not have such an adverse slope on it that it creates it violates the standard algebraic difference between pavements. So there is some tools in SS3 that will allow you to basically establish what we currently think of as a spline profile, because once you have laid out your corridor for your main line and you have the ramp transition part in there, you'll actually have a 3D model that you can then use the elements, the 3D elements, to essentially project to the ramp baseline and get a beginning profile, at least through the Gore area. And then once you have that, then you can continue on with the design of your profile. That's just one way of doing it. Another way is you could establish a spreadsheet where you have the profile of your ramp, and you basically could create intervals of 10, 20, 50 feet, whatever you decide is the most detailed, and you actually calculate profiles based on what you know the ramp super elevation is going to be, what you want your Gore slope to be, and of course what your mainline pavement slope at 2% is going to be. And establishing all of the, once you have it laid out horizontally, then you can establish the offsets and calculate the vertical elevations at each of those offsets, and then go in and actually enter the profile into the profile dialog, or use the VPI generator, however you want to design it. So there's a couple of different methods for that. So that's basically what we're talking about, designing a new ramp profile and then setting it active. Once you have that profile, then you can go ahead and associate the profile to your ramp corridor, because your ramp corridor basically has been built off the existing ground to begin with. So once you associate your design profile, then you can also associate the super elevation that you use for it, because the inside edge of that ramp will rotate according to the profile that you've established for the outside. Once you have the vertical geometry associated with the ramp, then you can go back into the mainline corridor and you can assign vertical point controls to the 2 points on the ramp that's coming off of the main corridor, and you can actually have it transition right into the basic ramp corridor. And then of course you'd use the cross-section viewer to verify the design. Now this is a very rough outline, but it basically assigns through the steps. I think the one thing I did forget to mention is that when you build this section of your corridor, which is the main line with the ramp or the Gore area, then the ramp terminal, that is, then you make sure you go in and add the corridor references as horizontal control, and that's what will actually pull out those templates. So enough of the outline. Let's go ahead and talk about an actual design and see an actual design out here. Okay. So first off, I just wanted to show you that once you have your ramp sort of geometry out there as far as the center lines go, then you can go ahead and I'm going to turn off these edge of pavements for the time being. Then you can go ahead and draw in the other edge of pavements, but what I did find was rather tedious, was trying to figure out where all the edge of pavements and shoulder lines and everything need to be in this transitioning area. And that's why I went ahead and built a simple civil cell, and we hope to embellish on these. And these are from, or this particular one is from Index 525, which is a single lane with 2 through lanes. The detail that's in the first page of those indexes. And you'll see there'll be, and this won't be in your DSG Live yet, because it's just something that we're working on, and hopefully we'll get not only this one but several of them, the other details that are in the same index, into the SS4 release as soon as that comes out. But essentially it's going to draw in all of the line work in between the 2 lines. What the 2 lines would be the main line edge pavement and then the ramp baseline. So as soon as I select that, then it will start prompting me, and it'll say, what is your edge of pavement line? And I'll select that one. And what is the center line of your ramp, or the baseline of your ramp? And it will select that one. And you can see it's now configured where the edge of pavement lines are going to be as far as where this physical gore needs to be based on the dimensions in the standards. So I'm going to reset and accept, and now I have some other lines that are out there, some temporary lines that basically determine what that transition distance needs to be, and also what the maximum length to the PC needs to be on that. So it'll assist you. We haven't worked out all the kinks on that, and then also it will figure out what the physical nose width needs to be and transition it back the required length according to the standards. So it basically draws out all those details. Now, what I was saying about your template drops, and I've actually modeled this one over here, so I'm going to start talking about template drops next, because once you have the 2D geometry laid out, then it's a matter of determining your template drops. And then I'm going to show you the various templates that I have out here. So the first template drop is obviously going to be right up until, which would be your mainline corridor, right up until where this point of your ramp begins. And you can do this, I have one template that basically goes across both roadways, northbound and southbound here on this 95 interchange, but I probably would design them separately. I would probably, and then just have a median that transitions, just because of the fact that these things could stagger, and you would end up building yourself way too many composite templates. So it's sometimes easier just to build templates by roadways and then just work out the details in the median. So now in this case, the next template drop will be, I'm just highlighting it here, it's going to be the area that goes right when the ramp physically starts, in other words, but it is not a full ramp until it gets out to the 12 feet section, and that's according to the standards. But then it basically is going to go to where the end of the physical pavement is. Not where the shoulders are, but where the physical pavement is. So that's usually where this is. In this case, this is, I believe it's in the standards defined as 19 feet. And so that's where I'll stop that template drop. So what I'm going to do is build a template that will widen out this gore area. Well, first it widens out the ramp, and then it widens out the gore area. And then once I've got it out to the physical, then I'm going to use this as a new corridor for the ramp. And I'll have to define the shoulder details in here, which we can discuss at the end here. But then I'll go ahead and place the rest of the mainline template will be from this section on out to wherever I'm going. And what that really is, it's just the extra widening to get it back to the mainline edge of pavement. So let's take a look at these templates and see how they're built. One thing that I have done is added these to the FDOT ITL in a special folder, which is the examples for training folder. And this one will be also delivered in the new SS4, well, and if we re-release SS3, it will be in there as well. So I want to just show you where that will be located. And just like we've done in the past with things that we've built for webinars and for our training class, I went ahead and put them in this examples for training. The reason we put these in here is just because we wouldn't want people to just kind of wander into here and start using them without having at least watched a webinar or gone through an exercise in one of our manuals. So within this, in this folder here, you'll see there's ramp terminals. And this one, actually, I should just rename this to ramp with, I'm sorry, main with ramp or something like that. But it's sort of named after the design standard, which is probably why I put it that way. But let's just look at the main, and I'll turn off, well, you can't see my template library, I'm sorry. So let me just back up and say that this is a new ITL file. And where we normally put these things is in this examples for training. So in this folder, you'll see there's a new ramp terminals folder. And then I've got 4 templates in here that basically correspond to what I've been talking about. So this is the main, and essentially this is just like I said, this one I probably would break it up, but essentially works off the active terrain and a right-of-way line. If you have a right-of-way line out here, then it will draw in the slopes based on wherever you're at on each side of the ramp. And this is just a two-lane ramp. I'm sorry, a two-lane main interstate type typical section. The next section is going to be the critical one here, which is this main, or I'm sorry, the main with a ramp. And when you look at this, it's basically got a few extra components in it. All right. And I actually changed the color of this so you could see that this is the Gore area. I happen to be using a stabilization component type, but you would normally use just pavement. But I'm doing that just for the sake of the presentation so you can see the difference. And what happens is this is the ramp, and the ramp is triggered off of this trigger line. So as soon as you add a ramp baseline to your corridor, if it's established, you'll see there's a baseline feature here. As soon as you draw this out here, it's going to start extending the ramp to the location. So this is what develops it. And of course, the Gore area is essentially 0. So the first thing you're going to see is the ramp baseline, and that's going to start to pull this thing out. All right, and then in order to get these two edges in here to pull out, and actually it's one edge, you're going to use that Gore edge of pavement line as a horizontal feature constraint, and that will basically move this thing out. Now, as far as the slopes, the way I have them laid out, and there's two different shoulder conditions here, but this is the ramp. The ramp is initially set at a 3% slope, and it happens to be tied to where the end of that search line is, so that's what it pulls it out there. Now in the Gore area has a couple different things. First of all, it's got a 0% slope, so it's just going to go flat out there to begin with. However, I've put a label in here which is the ramp Gore slope. So if you wanted to, you could use a parametric constraint to sort of slope this thing down, especially if you've got you know, if the profile of your ramp is starting to go down pretty drastic or something like that, and you need to control this algebraic difference, you could use a parametric constraint to begin with. But for the time being, I'm just using the 0% slope, and I would use that initially on this design. Okay, so then the next really template drop would be this main template drop. And what this has in it is just the same thing, only it's the Gore area, and it will also have this horizontal feature constraint for the edge of pavement. It also has the slope if you want to use this label to control the slope on that ramp as it goes back to the baseline. You could do that as a parametric constraint. But essentially it's going to use the other part of that Gore line, the taper back into the edge of pavement, to essentially take this from being out here at, I think it's 19 feet or 12 feet or whatever it is, to where it transitions it back in and has a normal shoulder. The other thing I've done in here is I put in a search line for the shoulder, so that the only way that shoulder will draw is if you add that shoulder line, because there may be a portion of time where you don't want to draw it and do some detail modeling in the little triangular piece. So the only way this is going to draw is if you add that full shoulder line in there. And it's only going to draw to a certain distance. That's why it was, notice if I'm way out here, it won't draw it. It has to be within the range of the shoulder. The reason it's set up that way is because it could find a ramp shoulder if you had it set to infinite. So I've got that set that way as well. So now let's take a look at this corridor, and you can see, and if I go to a right isometric here, we can take a look at how these work. So here's the main line going up to the point where the ramp starts. And then this would be the next section. This is the shoulder. This is how the ramp pavement actually extends out there. And then as soon as it gets to the 12 feet mark, it will actually start building the Gore area. And it's still, actually I can't remember if that's 12 feet. No, actually it's the 15 feet. So it's the full ramp width, that's what you're going to see. And then it will start to extend this, and it's showing up purple because I used that stabilization. And then it will basically follow that. Now, how is all this working? If we look at the, lost myself here. If we look at the corridor objects for this corridor, and if you notice, if I select here, it selects this part of the corridor. So these are rather long because of the location of that folder. But notice that I have the main template drop first, and then the single lane, the middle template, and then I have the main 2 template, which is what transitions it back. I've also got in here this ramp Gore slope. I used it to begin with to get basically a line established, but then I basically turned it off because I need that inside lane to follow the super elevation eventually. And then lastly is where you're going to start laying out all your point controls. Now don't get don't get too intimidated by all these point controls, but basically you've got let's just take a look at the PGL. These are basically the PGLs for the corridor. So they're controlling where the edge of pavements are. So there's those 2. Now the next ones are this left ramp EOP, and then the left pavement EOP. So what those are is this control right here. This would be the left ramp EOP. So what I'm going to do is add this as a horizontal, and actually that's not true. The external reference is what, so I have, actually no, I was right the first time. So yes, this line here is added as a point control to control this line of the ramp. Okay, and then after you get back through here, I basically made this line a point control within the range to essentially assign it to that other main corridor, main 2 corridor here, to basically pull that one back. So it's just a typical application of point controls within a range. As far as the external references, for this corridor, I have the ramp baseline, which is what triggers on this whole component set. And then these paved shoulder lines are essentially just to draw the shoulder in the right location. So the shoulders basically have to be widened out there, and I want to turn them on. The reason that you need to add the paved shoulders is because of the way this template is built. It has the option to use either, that's a good point, or a good reason to point this out. It has an option to build either, wait for this test window to come up here, either a shoulder gutter or a paved shoulder. So let's just draw this baseline out here, and then if it is a paved shoulder, it'll draw it off the end of it. However, if it finds a shoulder gutter, it will draw the shoulder gutter and guardrail, and then you'd have to build a slope off of that. So I left those in there on purpose because a lot of ramps will require shoulder gutter depending upon the drainage. And that is why you need to add in the paved shoulder external references or corridor references or whatever you want to call them, so that you trigger on the right component set for the shoulders. And that basically builds that in there like that. Now what I've also got, if you look at the details with the shoulder, turn on the paved shoulder lines here, I've added these shoulder lines here as references to the 2 separate corridors. So now I've got this ramp corridor, and that's what triggers on this shoulder, but it's not going to do it the entire length up there. It's basically going to stop it there. And then on this particular corridor over here for main 2, I'm adding this paved shoulder reference line up to there, and then I'm also using it, this line right here is also added to this corridor. that's one way of detailing it out. Actually, in this case, what I did is I actually went in here and built a shape with this miscellaneous shape out here, and I used a surface template to, and I obviously didn't get snapped to that point right there. That's the risk of using a shape, just a 2D shape. And what I did was built a 2D shape, made a surface terrain of it, and then applied a surface template to it. And I'm off a little bit here. I did that in the last 5 minutes before the presentation, so it didn't come out as cleanly as I'd like it to. Probably what you would need to do is go in here and have this shoulder line target to here, and then this target shoulder to there, and then have to use some profiling in here to basically transition those shoulders so that they slope correctly in there. But essentially, once you have that laid out like that, then you can, of course, you could use a clipping between there, but I try to stay away from the clipping. It adds a lot of overhead to the corridor, but it's still an option. It's still an option to use out there. So then if you just go to a cross-section view on this corridor, and I'll go ahead and expand it. I do want to kind of see where I'm at a little bit though. So we're going to just focus over here on this. I can change my vertical exaggeration, but you can watch it sort of get built here. So as you move along, this is moving every close to 10 feet. So I can also use the locate by data point. I know someone's out there probably reminding me that. So I'm going to move right up to this location and then start moving forward. And now you're going to see that this ramp is starting to get built. That's what this line here represents. And if I can get this to center on my current offsets, you'll see it start moving out. And the reason it has these two magenta boxes is because I've applied the, and I need to go back and show you that, I've applied the superelevation control to this point here from my ramp. But basically it's going to extend it out to there, and then as soon as I get into the area where the physical Gore starts, you'll see that the pavement now transitions both the depth, the pavement depth and the base depth, according to the way the standards have you do that. And then this is just showing you that this is the miscellaneous pavement, or the shoulder pavement, or the full depth pavement, whatever you decide to use in there for the Gore area. And if you look at the cross slope between here and here, it's using the 3% almost up to where the ramp starts, just because of the way the transition is. And then after that it will go into the ramp slope, which goes up to a maximum. And then this is that mistake obviously that I made with the shoulders. It isn't really designed too well there, but initially I had just not put shoulders in there. Eventually it will come back, and then you'll get your ramp peeling off that way. And then this is going to be where the transition is coming back into the edge of pavement. So let's talk about the vertical profile for this ramp. Okay, so once you've basically laid out your normal corridor design, what you have are the 3D line strings on your in your 3D model. Now I've turned those off, but if you wanted to see them, you would just go into your here and turn on these 3D lines. And then I'm going to show you how you can build this ramp profile. So the first thing you'll want to do obviously is to select your ramp profile and open it up. And then what I did was I used the 3D initially before I had my design profile. Let me scrunch this thing up. I used this vertical geometry profile by 3D element. And what I want to do is I want to establish where the beginning of this profile is from my model. Now there's a ramp corridor out here, that's in one model, but all along here with my transitions, my horizontal reference lines, basically pulling these out according to the template slopes, what I can do is get a basic a preliminary profile of where that would be if it was at a 3% slope, and then if this was at a 0% slope, I can pretty much establish this 3D line all the way up to the end of this physical gore. And once I have that line, I can come out here and use the profile by 3D element, select that line string in the model, and place it on the 2D line string. And what I end up getting is this line right here, and I'll change its feature real quick here so you can see it. So I'm going to just change this to like a right proposed profile, so it goes yellow. And based on your interval, it's going to drop in this profile. And there are times when these project profiles and profile by 3D elements will give you these little spikes. So this is the existing terrain, and then this is what it's calculated from my main corridor using that one template. So then once I have that, I can go in and essentially establish a new profile. I can basically place a tangent here, place a tangent here, place a tangent however you want to there, and approximate that profile of where it would be. Now this will end up taking control eventually, and then obviously your template, your vertical geometry will control where this ramp actually is. So it's kind of an iterative process. You use the slopes in the template to build this line, and then you can go in and design a profile that estimates that line and then apply it back to the ramp. So let's go back and look at the before I go back and look at the corridor objects, I want to turn on one other model here. So I've gone out and actually in my references I have this super elevation model turned on. So you can see that in the super elevation model I've gone ahead and given it a width, given it a standard to follow, and it's calculated this super elevation. So we can go look at that real quick and just turn off these views for now. So there's one section out here for the ramp, and it has, if we look at the super elevation editor, not the report, well, the report would show it to you as well, but the editor is always the wrench. You can see that my ramp starts out, if I could zoom out of here, it starts out at a 3%. You can see it down here too. And then when it gets into the curve, it needs to go to a full super of 5.4, and then it comes back down. So that's the super elevation applied to there. Now, it's not actually applied to the corridor until you assign it to the corridor. And also the vertical, you can use a vertical control on the other corridor as well. So let's go back here and I'll show you how that's applied. And we'll just turn on the profile and the model again. And now if I go to the corridor objects, for this corridor, which is the main corridor with the ramp, you'll see that there are two new point controls vertically. So one is the ramp profile itself. And all that's saying is that I'm going to use that for that particular point on my template, that outside point. I'm now going to use, I'm already controlling it horizontally with the horizontal feature. Now I want to control it vertically with the profile that I just created for that. And that will adjust it a little bit. And then the inside point the inside point of that ramp, I want to use the super elevation from the ramp, which is pivoting about that inside edge of pavement. So that's how you can control those two edges of that ramp. And then, of course, for your ramp corridor, you're going to just essentially have the point controls assigned via the associate super elevation to corridor, and it automatically builds that control for you. So one you have to manually set up, and the other one you can do with the associate assign super elevation to corridor tool. And as long as you have those points checked in your template, it would automatically assign those. So the only other trick one is that for this corridor, this point control for the inside is going to be within a certain range. And where is that range? That range is from here, this point right here, to essentially where the ramp becomes independent, this point right here. And it uses the super elevation in here. And it just so happens that this doesn't transition. It starts to transition slightly up in here, and then it really moves into the transition in this area right here. And that's according to the way my super elevation is described. Now, another thing that I'm thinking about including in our corridor folder in the next release, or we're talking about it, not just me, but in the corridor reference, I have the Spline Profile spreadsheet, which is what a lot of people, well, some people will use to develop their profiles. Let me just open this up and show you how this works. So in this case, it basically shows you that you would have a begin station for your ramp, a begin elevation for your ramp, a begin cross slope for your ramp, the Gore ramp station that you want to start at, and the elevation, and then whatever the slope is. So it's essentially this whole, the top row, and then down here at the bottom is where you would put in the end, well, there's the end distance, and then that would be the end elevation. And then this spreadsheet will automatically calculate the transitions for each of these, and what you'll end up with is a profile on your ramp that basically is this green line, and this would be your normal edge of pavement line. So it kind of builds the profile for you, and then you could go in and actually assign these elevations, and I think this is like a 10-foot spacing, and you could assign those elevations to points along your just basically store a vertical profile based on these elevations and a station using the VPI generator or some other tool. Now we're also looking into the ways of maybe exporting an XML with a basic existing ground elevation, and then maybe assigning those profile elevations to the intervals to help automate essentially building this profile. So there's a couple of different ways of doing it, and what you end up, eventually what you got to check is what is this cross slope on this Gore area. So if I open up that cross section model again and just we can start to investigate it, you can see how it changes a little bit. Here, and then locate by data point here. I'll go right here. Okay. And then you can place a temporary dimension line between here and here. And we can investigate how that Gore slope works. So if you move back, you'll see that it's increasing a little bit. I might want to adjust that profile down, or maybe extend the maybe lengthen that curve, or do some type of design analysis here. But this essentially allows you to hone in on it. Eventually, it'll go into this is where it's about -2 because just because I dipped down with that profile. And then if you want this to drain a specific way, you can control your vertical profile that way. But once you have all these set up this way, then it's just a matter of going in and tweaking this profile, because everything else is associated off of it. The super elevation, all the point controls, and that's what's going to pull this part of the Gore down. So even if I extended this curve, I don't know if I have enough room between them. It doesn't look like I do. You know, I'd have to go in and do some kind of modification to this, I guess. Maybe to adjust it up would actually be too high. So I'd have to obviously either lower this, I don't know, I'd have to do some vertical profile adjustment in there in order to get that to really transition or slope across, or it might be perfect. I mean, it depends on how you want to. If you always want it to run down across the ramp, then obviously I'd have to lower it a little bit in here because of the way that it's super elevating through there. I just really wanted to document a process. I know it's sort of detailed. I think once you lay it out once or twice and find out where all of your controls need to be, at least you'll have this recording to help walk you through it. So I'll remain on the line here. If you have anything that you want me to cover again, we still have a few minutes. Yes, these trigger lines, what I call trigger lines or search lines, someone asked the question, how can you turn these off or basically idle them? Essentially, it's in this view right here. If you look at this, you just turn this off, which is the cross-section miscellaneous PX level. Because in our templates, we use a specific cross-section miscellaneous component that all you have to do is turn that off. And that brings up another point. If your cross-section viewer happens to be slow when you're moving through it, this is the cross-section viewer, not the create cross-sections. What you can do is select all the levels in here and turn them off, and then just turn on the PX levels. Of course, not the one that one there. Any PX levels will be only the section components there. And there's another way you can just filter by PX if you want to use a star underbar PX. Jimmy showed me this a while ago. I always wanted to be able to filter them. And then that will draw, I don't know why that one didn't turn on, but that will only draw those, and then it will step through your cross sections a lot faster. As far as these yellow balls, those are in your model. It's the 3D line strings. So what I do to turn those off is I go to the F11 key and I go to the civil standards, and once this is turned active view, you can go to the features and turn them all off at once. That will turn them off there, and then the next time you move your cross sections, those yellow balls won't be turned on. Those are used for when we go to do the cross-section labeling with a new labeling tool. It needs to have those little point cells. And if those balls are too big, the other thing that you can do is, of course I'm getting into extra stuff here, you can actually go into the element template definition. I think Denise showed you some of this last week with modifying things that are in your design file. So in the corridor, so any cross-section point label, it's using the active point and it's scaling it up. And actually you can just take that scale off, but you'd have to sort of play with this to set however you wanted to. So if we just put in 0.1, of course I think I entered. Next question, how do you load the 4-window view in the DSGN file with plan, profile, cross-section, and 3D view side by side? You can use the F4 key. So if I had, if I just had one view open and I wanted to see all 4 at the same time, F2 will open up 2 and F4 will open up all 4. Now, when they first open up, they may not be assigned to profile and cross-section. And, well, these two will be. This will be assigned to the plan. This will be assigned to the 3D model. And then these two you'll just have to assign by selecting a line and selecting a profile, or selecting a corridor and selecting cross-section view in here like this. So let's see if I turn those back on, if these cross sections will be less intense. Yeah. And anyway, I showed you how you can turn them off. If you are using a regular constrained component in your template and not an end condition to act as a switch, is there a way you can set them to do not construct so they don't show up anywhere? Not if it is a normal component. So what he's asking here is, let's take a normal component. Let's say it's this shoulder pavement on this side. Whenever you use the do not construct option is only on end conditions. So here's where the end do not construct is. So I could check that and then they disappear. The line disappears. It's still going to solve, it's just not going to draw. Now what you could do, now that I think about it, see here you don't actually have that do not construct option. But what you can do is you can place a end condition across the top of here that uses some miscellaneous feature. You could use template miscellaneous for that matter. And then select from there to there. And I believe this is where, actually let me undo that one. And cancel that, because I want to turn on this, when I draw a end condition across the component, it gets associated with the component. Now it's really not doing what you want to do, but this is where you could actually do the do not construct on here and finish. And then whatever that line target is, if it didn't find it, it wouldn't draw it. See, there's actually 2 points there, so you would have to associate this line with that component, and then I think it wouldn't draw it. Yeah, I don't know. I'd have to investigate that a little further. But I don't think you can do it with a normal component. That's one thing. You can also assign a display rule, of course. You'd have to figure out a rule to decide how not to turn it on. Sometimes it's by length, sometimes by vertical. Well, I mean, your display rules, you have certain options that you can use. Any other questions? All right, I know it was kind of quick and I wasn't really able to go through all the steps, but if you have any questions, at least you'll have a webinar to refer to, see the steps that are involved, and we'll go ahead and get it posted here shortly. If anybody can think of any other great options for doing these things, feel free to email them or send them to us. I thank you for your attendance, and we can end this recording now. Thank you.